Hey, this is Stereo Police back with part 3, I believe, of the Yamaha R-9 natural sound stereo receiver technical discussion and review. And in part 3, as I promised, we are going to adjust, or at least confirm, that the idling current is where it should be, the bias, basically. But what that test really entails is plucking a plucking a voltage across the 0.22 ohm emitter resistor from the final, or from one of the two paralleled output transistors, the power transistors. And so the current flowing through, and this ultimately goes out to the speaker from here. The idling current, basically the current flowing from the collector to the emitter and on down. That's really the base current. I shouldn't have drawn that. As it passes through that 0.22 ohm resistor, it makes a voltage, or it drops a voltage across that resistor. And that voltage is in essence what we measure to determining idling current. We're just basically using that resistor to determine whether the idling or the current or the bias is correct. So, following the procedures from the service manual, number one, we have a no load and a no input setup, and I have turned the receiver on and have warmed it up for over 2 minutes. They require at least 2 minutes, but I've let it go for about 5 to get everything stable. And this is a depiction of the heatsink, and over here's one of our, we're going to do this for both channels, but here's one of our channels here, R553, excuse me, R553. And that resistor has these two little prongs sticking out of the top of it, conveniently for test points. So I've hooked alligator clips up to those test points, and I've run them over to the digital voltmeter, and the reading we're looking for is and auto class A is off initially, and the reading we're looking for is 10 millivolts plus or minus 1 millivolt, and that's proper idling. And if for some reason we don't achieve that, there's a little potentiometer right there, VR501, and that's it right down in there. I don't know if you can see it, but it's got it's a little pot, and it's got a little screwdriver hole in it for a tiny screwdriver, and right now it's pretty well centered. The slot is pretty well centered. Looks like it's roughly in the middle of its range. And the reading we are getting is 11.6 millivolts. And that is good enough. Okay? We're calling for 10 plus or minus 1, so we're calling for 11 millivolts, and the 0.6, I doubt I could ever affect that with that potentiometer, so I'm going to leave that alone. And while we're here, we're supposed to confirm auto class A. We're supposed to push the auto class A button and watch the bias increase to drop 60 millivolts instead of 10 across that resistor. So let's go ahead and push auto class A and watch what happens to the voltage. And we can see it rising. It's a fairly slow operation, but the bias is increasing, and we should hopefully get, what is it, 60 millivolts, or plus or minus 60 millivolts plus or minus 30 millivolts. Wow, that's a big range. I wonder if they mean 3 millivolts. But somewhere in the range of 60, and we have 53.9, 54 millivolts. Might be still rising as things are heating up. So that's within the stated range of unbelievably 60 plus or minus 30. That's a colossal range. I'm surprised to see that, but hey. So 54, it's slowly rising. So we're pretty spot on in terms of bias for this channel. So let me go ahead and repeat this this test for the other channel. It has to be done twice. Hopefully that works. Alright, so I've moved my alligators to the other 0.22 ohm resistor, and the receiver is already heated up. I unplugged and turned it off while I did that, but then I've plugged it back in. It's already heated up. It's producing a decent amount of heat. And there we are, 11.3 millivolts. You'll see a negative sign, a minus sign there, and that's only because I reversed the black and the yellow alligators just because it was more convenient to hook it up that way. The minus sign means nothing. So we have 11.3 millivolts. Let's confirm auto class A, and we'll watch it rise, hopefully in the range of, like the other channel, in the range of 54, 55. And we're heading in that direction. Yeah, I'm just waiting for it to get there. Alright, still slowly climbing 48, so it's not getting quite as high as the other channel, but then again, if the service manual is right, we're looking for 60 plus or minus 30 millivolts, so we're still well within that range. So there's a slight bias discrepancy between the left and the right channel in auto class A, but not outside of auto class A. But it's not. This isn't a defect or a flaw. It's just operating within its normal design limits, and I don't know why exactly there's that much of a discrepancy, but I'm not too worried about it. Everything is functioning normally, and this is actually still climbing. So the bias has been confirmed. It is working, and so far everything else is working. To my knowledge, I haven't tested every single function on here. I'm mostly concerned about the integrated amp aspect, but now's the time. We can use the same resistor and put a scope across it, and actually get a look at what the current is doing and determine when the amp switches over to class AB from class A. And then we can measure the voltage across the load and determine at what wattage that happens. How many watts do we get out of class A? Because the service manual and to my knowledge, the operator's manual does not state the class A wattage, and neither does the service manual. Unlike the A1000 that stated 10 watts, and we verified it's 10 watts, or roughly 10 watts. So go ahead and get that set up, rigged here, and we'll take a look. Okay, we're ready to determine how much class A wattage that this thing can dissipate or can supply. So just as when doing the bias test, I have a couple of alligators hooked up to the 0.22 ohm output resistor. And that resistor we are looking at on my battery powered scope, because it is effectively a differential measurement. And I can't reference either side to earth ground. Actually, there's a way I could do it, but I prefer just using the battery scope. It's a lot easier. And I've got two 8 ohm dummy loads hooked up to left and right channels. And the amp has been on and running and warmed up. And I'm going to start out in class AB mode. And I've got my accurate voltage. I've got Keithley voltmeter hooked up across the 8 ohm load, and we're going to take that voltage measurement at certain points and determine wattages. And the blue signal we don't need to look at. The yellow signal, I have the volume down, but the yellow signal is looking directly across the dummy load. Alright, we can read our RMS voltage right there, as well as frequency. It's 1 kilohertz. I'm sticking with 1 kilohertz for now. Alright, so again, this yellow is we're looking across the speaker load. This battery powered scope, we're looking across the 0.22 ohm resistor. So we're getting a picture, an actual picture of what the current looks like flowing through the emitter of the output transistor, of one of the output transistors. It's going to be the same, about the same for all. Okay, so I'm going to turn the volume all the way down, and I'm going to start to increase the volume. And as you can see, we're looking at the waveform across the emitter resistor, and right off the bat, it's looking like class AB. Way down. I mean, and this is as fine as this little battery powered scope can go in terms of vertical volts per division. So I wish I could make it bigger, but I can't. But so we're kind of into class. That looks like a class A signal, and that's what class AB amplifiers are. They're just slightly biased into class A, and then they leave class A within the first fraction of a watt. And I'm going to see when this thing leaves class A, not in class A mode, in class AB mode, and I'm going to turn it up until you start to see that telltale flat. It's kind of getting like a weird sine wave now. Now it's really flat on the bottom. So it's left class A. And we are at 3.41. Let me get this. 3.3 volts RMS across the 8 ohm load. So that's basically a little less than 1 watt, right? 3 times 3 is 9 divided by 8 ohms. A little more than 1 watt, but about 1 watt. So somewhere between, if I back it down, that's kind of class A, and that's 2.57 volts. Okay, so somewhere around the 1 watt range is when you leave class A and go into class AB when not in class A mode. Okay, so let me crank it up again so we can start to see that. Okay, you can see that telltale flat at the bottom. This is definitely in class AB now, and we're back to 3 volts. We're at 1 watt. Now I'm going to push the auto class A button, and I'll tell you when I'm going to push it. Okay, right now. I just pushed it, and you just saw that waveform clean up into a nice, fairly clean sine wave. Okay, so we're into class auto class A right now. Now I'm going to crank up the volume until we start to see the transistor going into cutoff again. And you'll notice that by the flat, the bottom, we're just starting right now. You'll see that flat at the bottom. That's the output transistor going into cutoff. And that's really class B there. So I'm going to back it down to where it's still kind of class A. It's kind of there. It's got a curve at the bottom. It's distorted. It's trying to cut off. And let me give it the boom. Boom, it just snapped into cutoff. I mean, that's literally a snap right there. So let's say if that is officially class AB, we're at 9.8 volts. So 9.8 volts, that's effectively 10 volts. I mean, so that's basically 100 divided by 8 ohms. That's 12.5 watts. So again, somewhere around, you get somewhere around 10 watts of class A. Now let me back it down to where it's very nice and nice clean sine wave, and we're at 6 volts right there. So that's 36 divided by 8. That's 4.5 watts. We have a nice clean sine wave across the emitter resistor. Now I'm going to turn off auto class A. Get ready. Okay, off. On. Auto class A is on. Now I'm going to turn it off so you can snap into class B. Right there. So that kind of confirms it, that we do get, just as in the A1000, we do get roughly 10 watts of class A in the auto class A mode, and we get roughly 1 watt of up to 1 watt or so of class A in class AB mode. So there you have it. I'm going to do the same for the other channel just to make sure everything's balanced and functioning normally, but it would have been helpful if the owner's manual or the service manual told me what to expect, you know, how much Class A power I would get, but it didn't, but that's okay. I just confirmed it. So there you have it. That's really all I wanted to do today. I think I want to get this thing wrapped up, and I'm not sure there's anything else I want to do, and get it wrapped up and put together and put it on the hook it into the stereo and give it a listen. Thanks for watching. Ciao.